challenging ones. And then, so this is like our last week of kind of the usual labs. Starting next Tuesday, we're going to transition to microscopes. So it'll be a good change of pace, and then we'll kind of do that for a while, and then we'll be on to unknown projects. So I put up a note to remind myself to say that on Thursday we're setting up a disinfectant lab. So you're more than welcome to bring a disinfectant from home if you would like to test something. So it could be maybe something that you use to clean around the house with. It could be hand sanitizer. Sometimes people bring in mouthwash or like eye contact solution. So if there's something that you're interested, you don't need very much, or whatever's easier. If you want to bring a little sample, if you want to bring like a little bottle of it, that's totally fine. But for sim, so what is this? This is lab 520. So the media that you guys used, it was called a Simtol. It's called a Simtol. And then so the Simtol, as far as what's in there, what's nice is we don't have a lot of pieces in here. So it says digested casein, which is basically our peptone in there. And then the other thing too is what's maybe a little bit strange is it says digested animal tissue. So we have digested animal tissue. So essentially it's going to be kind of like extra peptone. But we're going to go back to the digested animal tissue because we're going to think of this as kind of like extra amino acids that's thrown in there. And we're going to focus on that for just part of our sim test. Other than that though, we have an ingredient you guys have seen before, thiosulfate. So we've seen that before. I kind of wanted to clarify it again though, because thiosulfate, like it's come up on a lot of the labs. It's not organic, so it's not in any of the categories that we've talked about. It's not an amino acid, it's not a sugar. It's actually just a really, really small molecule. It has sulfur and it has oxygen in it. So we have that. And then really other than that is we have the ferric. We have some ferric. In all the other labs though, it's always been ferric citrate. Here it's technically ferric sulfate, but I don't want you to really like worry so much about the sulfate part, so for quizzes or whatever, if we said ferric citrate instead of sulfate, like that's fine. The most important part is just the ferric. So, because I know it is a little confusing that now all of a sudden it's sulfate, but we have the ferric in there. And then the last thing is there is a low percentage of agar. Okay. Low percentage of agar. All right. So, okay, so let's break down. So we're gonna collect the sim. The purpose has motility, indole, hydrogen sulfide gas, but our focus is gonna be on the indole component. So let's start off with the S. The S is representing sulfur reduction. So just to clarify what that means, so basically on the sulfur reduction part, we're just gonna see if your organisms can metabolize molecules with sulfur. So for the sulfur end, or the sulfur reduction, we have two options. So one of the options is actually connected to that animal, that digested animal tissue. So, so that animal tissue that's digested up, basically the reason why they kind of added that extra piece in there is because we want to make sure there's plenty of amino acids, and there's one amino acid in particular. We're just going to see if your organisms can use it for food. We kind of mentioned it in lecture. It's called cysteine. So cysteine is unique because it actually has, it's actually an amino acid that has sulfur in it. Sulfur based. Not too many amino acids have sulfur as a part of their chemical makeup. They have carbon and they have nitrogen and hydrogen, but sulfur tends to be a little bit more rare. So anyways, we're going to see if your organisms can use it as a source of food. In order to actually break it down and use it, they have to have an enzyme called cysteine desulfurase. Cysteine desulfurase. All right, so if they have that enzyme, they'll break down the cysteine, and then the end product is that hydrogen sulfide gas. The one that kind of, it'll probably smell a little bad today too, that hydrogen sulfide gas. So we have that. And then I guess the only thing maybe that makes this lab a little bit different is, so we have the cysteine in there, yes, but we have another option, so I'm going to put an or. So your organisms may just end up eating the cysteine, or another option for them is maybe they don't eat the cysteine, but they use what's called thiosulfate, because we do have thiosulfate in the media as like option 2. So, so they might be able to metabolize the thiosulfate. It's technically a different enzyme though, so we've called it thiosulfate reductase. But the end product is the same though. So hydrogen sulfide gas. So we end up with actually the same end product. So I guess maybe the only thing to say is that if you guys run this test, it could be option 1 or it could be option 2. In order to see the hydrogen sulfide gas though, basically the way you're going to see it is with the ingredient number 4, we have that ferric included in there to help you with the visual. So this test is very like visual based. It's very differential. So we have the ferric. The ferric will go ahead and label the gas either through option 1 or option 2. Doesn't matter. It'll label the gas and it will turn it black for you. So at least the good part is it doesn't matter what lab we look for hydrogen sulfide gas in. We always get black, right? So that part doesn't change. So we have that. So that's the S component. Oh, maybe the other thing I'll add, so if you see the black, you won't necessarily know by just looking at it, like if it's option 1 or 2, if that makes sense. So if you get the black, you'll just know that, yeah, you have the hydrogen sulfide gas, but you won't be able to tell by just looking if it was the cysteine or thiosulfate. All right, we have the I part. I is representing indole. Representing indole. And I'm going to put a star because this is kind of kind of the whole kind of point really of doing the lab, because it's part of that IMVIC that we mentioned last week, IMVIC. So the I is up here, indole. And we already did these other labs last week, the methyl red, the Vogue's Pascal, and then we did the citrate. The indole part is actually pretty straightforward. So again, we're back to the animal digest one more time. So at least on the indole part, it's not as complicated as the MRVP. The animal digest has another amino acid in it called tryptophan. So it's got cysteine, it's got tryptophan. We're just gonna see if your organisms can break it down. So they have to have an enzyme called tryptophanase. Tryptophanase, so that they can hydrolyze tryptophan. So when they do that, they can basically use it as like a food source. So if they break down the tryptophan, they'll actually end up with pyruvate as an end product. And pyruvate is great because pyruvate is kind of that fork in the road. It's a really important molecule that bacteria can use to build their ATP. So we have that. But then there's kind of like just another byproduct. So it's not just the pyruvate, but there's also, I'm going to put a plus down here. There's another byproduct that is made too. We just call it indole. So indole is probably not anything particularly helpful for the bacteria, but it's kind of a byproduct. So all you guys are going to do is you're just going to dump in a chemical and you're going to label the indole. So that'll be a pretty straightforward part of the test. Just kind of pour on the chemical. So I'll tell you guys how to do that. And then really, other than that, it's just, I guess, the motility. Let me squeeze over here. Motility part. So motility. All right. So for the motility, you guys can also grab like a quick visual. We did motility once already though, right? Does anyone remember the lab we did it in though? Yeah, the OF, the green one, the oxide. So we have it one more time here. You guys, the tall, remember we said it looks like you should boil it, but we didn't. So we did like the single stab. And technically there's a low percentage of agar in here too, just to give your organisms a little wiggle room, if that makes sense. And then usually if they're modal, they'll kind of jet out a little bit. So along the stab line, it'll kind of puff out and have like a Christmas tree effect, if that makes sense. One thing I did want to add though, because you're probably going to have to do it on the organisms from today, is that sometimes too though, like it might be hard to assess what's happening along the stab line. So you can definitely check out motility like up here, kind of like on top, in the sense of if they're kind of like moving around, what'll happen is they'll kind of spread out, even like in that top film layer, if that makes sense. So when you kind of look down on it through the cap, you'll notice that it might kind of, you'll have more of the spreading effect on the top layer. So, but anyway, so you can check out the motility. We'll look for the black, but then the most important piece is we'll gather the indole. So let me tell you guys how much chemical to add, and then that'll be it for the, but do you guys have any questions about anything there? Yeah.
Can you explain explain the difference between the digestive casein and the digestive animal tissue? Because it says
yeah.
both as peptone.
It's both, yeah, it's both peptone. I think though, the reason why they added the extra is, I mean that theoretically it should be the same, but I guess it's like just in case there's not enough cysteine, in the casein, to kind of do the animal tissue. So, yeah. So like the milk protein might cover it, but they add the extra, like just in case, so. Yeah, yeah.
For the indole, would it be a differential due to the?
No, you're right.
Yeah.
Yeah,
So
you know,
would it
you're
be a
right.
differential?
Yeah, definitely. Yeah, the indole will also definitely be a differential.
Because
Yeah.
it labels the indole.
Yeah. So we actually, related to his question. I mean, we have kind of like a lot of different parts that are differential because it's not just the chemical. We have like you could say that animal digest like helps with the color too. The ferric part can help with the color development. So yes, definitely. All right, let's do, okay. So, for your day 2 methods are gonna be pretty easy. So at least today, it's not like you guys have to pipette anything. So I guess the only thing to do is you guys will wear gloves. And then, for the indole test, so the chemical, it has kind of a strange name to it. We call it Kovacs reagent. And we have it labeled as Kovacs in the glass cabinet over there. But you'll go ahead and you'll add 1 dropper full. So just go ahead and fill it to the brim, fill it up. So there's like a little dropper in there. You might even have to add a little extra than that because I noticed in the morning it was kind of skimpy. So what you want to do is you'll add that and you guys have a control. So you'll add it to all 3 of your talls. You basically want to add enough so there's like a thin layer of chemical on top. So that's kind of the goal. And then just to clarify, because I think it is a little confusing, the way this works is, again, that byproduct called indole. We're hoping that it reacts with Kovacs together in your test tube. Your lab manual, though, says that when the 2 react together, you get like a cherry red. I noticed with our chemical, though, it's more of kind of like a pink red. To me, it looks less red and more pink. So that's okay. We're looking for kind of that pinky development. And then if you see that, then you're definitely positive for indole. So that's what we'll check out in our test tube. So if you guys want to grab your Kovacs, I'll pull out your sim talls in the back area there. Yep. Top layer that we mentioned, and what should happen is you'll see that the P. mirabilis moves around a lot. E. coli also kind of moves around in the top layer. In the stab line, it's like a little less so, but towards the top, it'll kind of sprout out a little bit. So they're both positive. It's just the E. coli is a little bit more, I guess, subtle about it. And then which one was positive for indole? Hopefully your E. coli, yeah. You kind of get the pinky red. And then the sulfur reduction should be the other organism, the P. mirabilis, and E. coli is negative. So, all right. So you guys can take your time finishing up your drawings, and then if you want to hold on to your gloves, oh, bless you, go. You want to hold on to your gloves for the cleanup that we're